Welcome back to the Integrate Intelligently podcast. I'm your host, Jeff Brickler. Today is episode 11 of season 2, and we're talking about manufacturing. Surprise. And today's title is Manufacturing is Complicated, and How Can I Simplify It? So, Scott, it's good to see you. A little worn out, just was on a meeting but right before this, but welcome to the conversation about manufacturing.
Absolutely. One of my favorite topics. Obviously, it's like, it definitely can be complicated sometimes. So looking forward to talking about that and process and things like that. So this is hopefully we get a little nerdy on this one. Maybe people will, if you really like that kind of stuff, you're going to dig it right in on this one. So.
Yeah, so it'd be good. I think, I learned manufacturing from you, and then talking to customers and helping people sort of more on the job training. And you, of course, studied it and then worked in the industry, right? I think one of the big things that I like about what we do here is you were in industry, and a lot of the folks who work for us, our industry, had that industry expertise, right? Been on a shop floor, had ERPs, had CAD, had these same struggles. So that's a nice sort of, what do we call it? A nice real world experience, I guess. Something that I myself don't have on the shop floor, but I have it kind of vicariously through you and through our customers. But a lot of our staff have been in that area, right? Working in manufacturing companies.
Yeah, I think it's a differentiator for us. I mean, we're not just a software house that who just tries to peddle the stuff and then just, without some kind of industry insight. We especially the people that we have implement the software, we look for people who've got a decent amount of experience working in those customer environments, because they had they've lived with the problem and they understand the nuances of it, and they can consult and they can hopefully help with the complexity problem that we're going to talk about today, and streamlining that and really helping with that. And I think it's really important in software that you can kind of pair it with these services with somebody who has kind of the best of breed or best practices kind of baked into it to help you make those decisions and navigate that. Because we do this every day, right? So the chances that you're going to be good at this on day one, having never done it, is probably very small. So therefore, can we have people who've lived with the problem, who've been through it, sometimes used to be customers or users, and how can we bring that forward so you can kind of stand on their shoulders, what they've learned, and do it even better.
Yeah, it's like anything else. The more you do something, the more details, the more you learn, the more nuance you get into it, and how that nuance can be important. So, no, it's good. So I think today, Scott, we're talking a bit about complexity in manufacturing. I know that when I was learning about it, there were the thing that I've always thought was most complex was the vocabulary. Just so many different words to describe the same thing. Right, like I can't tell you how many different words for a part, an item, an inventory item, a stock code, just all the different words. That's what got me. But today we're not talking about vocabulary really, but different manufacturing processes and the complexity around those. So I think by nature, manufacturing has different complexities, right? Different products have more or less complexity. I was talking to a gentleman just before this. They make like rodeo gates. They make rodeo gates and like cattle gates and types of livestock equipment. Well, he kept saying, our products aren't that complicated. Because he explained it. I said, well, yeah, it's not a rocket engine, or it's not it's really a complex electronic device or mechanical and electronics on a car, but nonetheless, everything has its own complexities built in, right? And so today we're going to talk about those complexities, both in engineering and manufacturing, and different levels of complexity, right? Complexity can be in the type of products you have. Complexity can be in the number of products you have, right? Not just the types, but the number of products you have, or the variations of products you can have.
Oh, yeah.
It can be in the variation of raw materials that you need to use. There's a customer that I worked with who had worked on government contracts, and they had specialized material. And they had to design, they would design something. They designed something just like it before, but this time they had to make out a different raw material because they had specialized corrosive or, some need that was unique. So manufacturing can become complex in so many different ways, not just simply the structure of the bill of material. Like I said, it can be because of the different configurations you might have, the different types of products you have, the different manufacturing processes and material types you have to use. I mean, just a whole host of things, right? And anytime you increase variables, you increase complexity.
Yeah, yeah. I think there's also complexity of process too, right?
There is.
Like we talk about that quite a bit. It's like generally people when they see variation in things, they tend to add complexity because they see they can see the differences. There's like pattern matching and pattern. There's different. Like I remember seeing this years ago with Tony Robbins. There's like different ways people think. Some people think of things and they go, "Look how similar they are,"
Right.
and then the same. Then other group of people look at it like, "Look how different these things are."
Yes.
And then there's like different ways people kind of frame the world, and you see that a lot. Like you should probably see a lot during product demos. Like people will, they're kind of like they're contrarian versus they're agreeable, and then different kinds of ways they approach things, and you see that also with complexity around systems and process, as well as like they go, well, this isn't the same as this, so therefore it requires a completely different process,
Right.
and those are typically like not pattern matching. They're a different kind of mindset, of more contrarian of like these things, they see the differences. And then you see other people who are like, see everything as being the same. It's like, well, that's just a variation of that same thing,
Yep.
and they can combine the concepts and they're able to get to a higher abstraction layer. But sometimes they'll try to do things where they make, yes, rectangles or squares are technically rectangles, but they're not the other. You can't go the other way, right? And that's in programming we call, I think it's called polymorphism. It's like this idea that you can go too far with that and try to make too many things too similar when they're not.
Correct.
So there's pros and cons of both approaches, but complexity tends to drive somewhat out of those beliefs about what things are. And then being able to understand the nuance of like, is it actually that different, or is it just a variation, or just like, where does the complexity sit in that process, or in that system? Yeah, like we get really nerdy on this, like systems theory and things like that, about how these, how things are built and stuff. But like, I think we can, for the sake of the audience, kind of keep it, try to keep the concepts kind of more straightforward.
Yeah. Before we got in, I wanted to share when you talked about that, you can types of people can see like these things are similar or things are different. What I immediately thought about, we lost our dad here recently, and so one of the things we talked about, I thought about was like how as a kid, I remember dad would always be showing it because they're mechanical, right? Dad was very mechanical and he liked to work on lots of different things. And he would always talk about, I remember he would just say like, it's just like this other thing, right? Like I remember we were working on some engine or car, I don't know, something. I have no idea what it was. Obviously I didn't become an engineer for that reason, but like, we were working on something. I mean, he would say, it's just like this other car or this other thing. And I remember thinking, dude, I'm struggling with what you're talking about here. I can't compare it to this other thing. So, but my point, I guess, the making is that like, from a young age, I don't know if like this resonates with you. From a young age, I always remember thinking about, dad would always bring that up. Like, oh, it's just, these things are the same. They're the same thing. They're the same thing, the same thing. So many different ways in life. He'd think, oh, it's just like this, plumbing is just like something else. Or it would, I don't know if you remember that, if that was just something that
Oh yeah, totally. I mean, it's called analogical reasoning. So you can draw an analogy to something else and it's kind of how you learn, right? You learn through analogy. So you're seeing, and I think it's a sign of a higher level of understanding. So that's how you're able to like reframe concepts. Like Richard Feynman talks about, if you can explain something to a 5-year-old, then you really know it.
Right. You simplify
the ability to draw analogy and to see the similarity is in order to break it down to its core concepts. But that's a more higher level understanding than like, so typically at a lower understanding, all you see is complexity. And then at a higher level of understanding, then you start seeing simplicity. And it just depends on like how well you know the thing or things like that. So dad was very mechanically inclined and he was able to see the patterns. Mm-hmm. Recognition was a skill that he had, and he could draw those analogies to different things. And that allowed him to bridge the gap between what he already knew to the new thing he was trying to learn. And even if that analogy wasn't perfect, or your assumption about how it worked wasn't quite right, it still bridged it. So he could get there, and then he could learn more, and then he could start seeing. And then what's interesting is you learn more, then you start understanding the nuance of where it's different again.
Right.
And then, so it's that idea around like, that probably a curve to that, or something you can talk about, like, this, like, uninformed optimism type thing, where like uninformed and then understanding, and then you start getting really informed and you start saying, well, this is like the same. And then you get a little more informed, you're like, well, there's nuance here. And you're just kind of oscillating back and forth between these concepts, but I think it's different levels of understanding of how things work.
A bit like the Dunning-Kruger effect, right? Where you might go, I understand, you learn a new topic, you understand, like, I get this because it's something like you've seen before, right? You get this really high confidence, like, I really understand this. And then the more you go along, you go,
Mm-hmm.
wait a minute. Yes,
Oh yeah.
yes, there are lots of similarities here, but like there's a lot of differences that I didn't
Yeah.
realize. I fell into that trap. So obviously, you went to school to become an engineer, and I went to school to study Latin. I couldn't do two different things, but I studied Latin, and that was fine. And I had always just studied Latin for years and years. And then I started in college. I had to take Greek, and then it led to German, and then French and Italian, and lots of other things. And I remember when I would hop from Latin to Greek. When I started Greek, it was the first language I had learned after Latin. So I'd already learned Latin 6 years in high school and the first year in college. And I remember thinking, oh, this Greek was just like Latin. And in a lot of ways it was. In a lot of ways it was. And so I think probably first year, right, I just leaned heavily on my ability, my Latin skills, because like it looks so much. It's like, oh, the grammar is very similar. I would not study as much because I could lean on my Latin. But after that first year, it's a Dunning-Kruger effect. After that first year, that
Mm.
Latin was not useful anymore because like the real complexities of language came out of
Oh yeah.
Greek, and like it didn't help anymore that I knew Latin. It helped in the beginning to learn it, and maybe the first year where you're kind of learning the basics, but after that, the complexities went up so much that I couldn't do it. Same thing happened to me in Italian. There's a bit of arrogance on my part. Oh, I know Latin, I know Greek. It happened to me in French too. I'd take a language and I'd go, oh my God, this is so easy, because the words would
Mm-hmm.
look alike and the grammar. I was like, this is like Latin, but simple. Right. And there's a
Oh
little bit
yeah.
of an arrogance about me. And then of course, in the classroom, it's one thing, right? I like an arrogant young kid. I didn't even study for the tests or anything, because like I had so much language background, and I was in a class of kids who were students my age, kids who were doing the same subject for the first time, or they weren't exposed. So I got you get away with murder because you don't.
Yeah.
And I didn't put the effort in. Then I went to France, or then I went to Italy, and the Dunning-Kruger effect took place. It's like,
Oh
I
yeah.
don't know what I'm talking about. I don't.
Yeah. You can read the signs, but you can't order food,
Yeah,
right? I mean, it's
I
just
can
like
read the
that. It's
signs,
that,
but can't order the food. I,
right. You can't do the real basic things of everyday life that you think you can, but you can't. I definitely had that experience with languages. You feel much more proficient than you actually are when you're under pressure, and you actually have to do something. I remember being in Italy with you, and the guy, we didn't have train tickets, the right train tickets,
man,
and the guy came up to us at the train. And he was asking us like for our tickets, and you're trying to communicate in Italian, and like high pressure, right?
yeah,
Your brain shuts down. You don't know what to say. It's just like that's the real deal there. That's understanding when you're in a situation like that. Yes, you might understand what the guy says, but you can't generate the thought and then get it out of your mouth. I mean, it's a different level of
it
understanding.
is. Under pressure.
Level of
No, it's
complexity.
100%. I'd been living in Italy for 4 months, and I had some fluency. I wasn't like, languages have, people use the word fluent, and they always think like you're either fluent or you're not. There's levels of fluency, just like everything in life, right?
How how fluent are
How
you?
fluent
Yeah,
are you, right? So
right,
how
right.
fluent was I? I was probably like a beginner intermediate. Like I could have some basic conversations. I could understand basic things. Um, but when we're on a train and we didn't buy the ticket, and the guy's yelling at us in Italian about how we didn't get our ticket and all this stuff, every ounce of everything I knew, didn't matter how much Latin I knew, how much Italian, it didn't matter. My fluency wasn't there, right? I couldn't do it. I think we ended up having to pay a fine. I think we had to, what we pull out of our pockets, every currency. This is before the euro, so every currency possible.
We had to pay in Swiss francs.
Right.
Yeah, it was like, but yeah, it's like that. That's what shows like the example of like just the way different people think, right? And then and if you think of you think you understand, then you don't understand, and we see that. I mean, a lot in implementations
We
too, right?
do.
People think they understand the problem, and they oversimplify it,
Yeah.
and then as they see the nuance, we talk about this a lot about the idea of linking versus transformations, and why we do it the way we do it, and what drives that, and it's just I guess similar story. Not to get too much of a tangent on the stories, but I remember when I first learned about databases, and I learned about Access databases and creating them, and I learned a little bit of Visual Basic and coding and stuff. And I remember we were implementing Sightline ERP at the time, and I remember telling the guy in the IT department, like, all this is an Access database with a Visual Basic front end. That's how this thing.
It sounds
And,
just like me. Oh, Italian
oh
is
yeah,
just like Latin, just light.
yeah,
It's like light
yeah,
Latin.
yeah.
Yeah.
And just like, and the IT guy looked at me, and and it was like, I mean, conceptually correct, right? It's like
Conceptually
it's a front end.
correct.
Yeah, there's some programming language that talks to a backend database, but like to roll it into like there's only one database possible, which is Access, which is all I knew about. And then you must have written to BGPB because that's where everybody writes their stuff in, and it's like, no, there's like thousands of languages that people could write things in. And it's just that you just don't have enough, you don't have enough information, but you have the concept, but it's not correct, right? And that's where then you learn more and you start saying, well, yeah, like, yes, there are lots of databases. There are lots of complexity around this, but you need to learn more. Like most of them are relational and they work like this and they're pretty similar. And you start seeing this the same again. And then, but this one's actually a document database. It doesn't work off the traditional relational database issues. I mean, so you start just getting into these kind of subtleties. And I think that there is a huge tendency around that problem of the more you know, sometimes the more complex you'll make it. And then then sometimes the more you know, the more opportunity there is for you to make it to simplify again. But it's really part of your process if you do that, if you go through that refinement or not.
Sometimes I think it hurts. It does both. I've seen both. It's like, this, but for myself, I've done this, but I think I've seen it with when I did projects. Two types of people, right? Like, well, probably more than two, but like two types of people I've always seen is like one person who, to your point, really in depth will overcomplicate, right? Like make it complicated. Another person who like knows something and then oversimplifies. This is just like everything else. The problem is simple. It's not that complicated. And then you end up getting one of the two spectrum, right? Which is like either one guy, I mean, I usually work with engineers. One engineer just says, oh, it's just like this other thing. Simple. I know what this is. Easy. And another guy is just like, well, no, there's this complexity and this complexity and this complexity. And it becomes this whole web of stuff. And right. And then it's like, either one guy makes it too complicated, doesn't want to do anything. And one guy makes it too simple, doesn't want to pay anything, doesn't want it. This problem's not that hard. You're like, well, it's actually somewhere in between, right? It's not.
Well, the rodeo kind of example you had earlier with the guy with the rodeo stuff, it's like I'm making gates for a rodeo, and you're like, I mean, how complicated it be? I'm not making jet engines here, and you're like, well, I mean, what's the, well, you could look at that a couple different ways. And then then you're basically a commodity, and whatever you make isn't really that big of a deal, and anybody can make it. And it's not, it's not a big thing. And you're like, well, no, because you can just frame it another way, right? You could just say, well, obviously, your business isn't really worth that much to you because you're not doing anything special. Oh no, it is. We do this special thing, and when the bulls hit it, we can react to it, and you start talking to them about it, and then it's just like, wow, well, it seems like a pretty complex thing that you're doing there.
Yes.
So it's like, so it's really kind of, there has to be, if you have that's interesting thought too, is if you have a viable business creating value in the world, how are you creating that value? If it's so simple, if it was so simple, anybody could do it. How would you create the value?
Right.
Like, so you can say, well, we do it because we differentiate on cost, so we just do it cheaper. But you still have something complex, something nicely complex, something interesting that you do that other people can't easily replicate.
Right.
So that gives you that advantage. Either you figure out a way to do it more cost effective. You've done something, you've actually figured out how to make complex simple. So you can actually bring the cost out of it to be the low cost provider. You're doing some innovation that provides a value over and above what a typical solution would do. It's all these different ways to differentiate in order to make a viable business. So, but all of those things do have complexity. They all have those nuance to them. So yeah, I think it's a very common thing. People will kind of either reduce to overly complex or overly simple, or they will inflate to overly complex. And usually, like you said, it's somewhere in the middle of these types of processes. But yeah, absolutely.
The golden mean. That's something that when I was in school, you learned about, right? Like you see it, you see it every day. The golden mean is like the golden middle, right? The mean is like the mathematical.
Goldilocks zone?
Yeah, exactly. Yeah, this is before Goldilocks, of course. In Latin, it's highbrow, like high education. They called it the golden mean. That was like a theme in literature, in ancient literature, and talk about like finding the Goldilocks zone. It's the same idea.
Yeah. Oh yeah. So it's but yeah, I mean with complexity, complexity typically is is usually bad. I mean, as a general rule, it doesn't mean it just exists, but it tends to be, you can have complexity and outcome without the complexity of process,
Oh
right?
yeah, good point.
So that would be like, to everyone else, this is a very complex thing that you figure out well enough to make simple through, usually through abstraction or a way of thinking about it or expertise, that to anyone else trying to implement it would be complex, but to you is actually quite simple. There's where the arbitrage or the advantage is to create a market to then create a business. And so from a manufacturing perspective, I would say that whatever, like all of these things that we create to someone else are infinitely complex,
Mhm.
to the uninformed, but to the informed, they're not. And that's the whole value creation equation, which makes economies work.
So Scott, I mean, obviously you've stuck with this, with the CAD integration or the engineering integration with the ERP for a long time, and you talk to customers, and I have too. What are some of the common mistakes companies make in terms of complication of process that they do? I mean, in terms of, because you used to implement ERP as well, so I'm sure you saw, talk to customers, do the discovery, do all of that, and then they would come back and go, "Well, we got to do it this way," and we. What are some of the things that people have done to look out for, right? That if the listeners are here, say, what do I need to be a risk of doing? Like, shooting myself in the foot, overcomplicating. I'm implementing. Say, as you're implementing a new ERP, what are the things that you should avoid in terms of overcomplicating?
Yeah, I think that idea, the special snowflake syndrome, you see a lot of out there, that like they think that their thing is, and the thing of it is that they're right, but they're wrong at the same time, right? So they're able to, so if they're mismatchers, they're looking at what the differences are. They're like, man, we just do something special that nobody else does in the world like this. Like, and our concepts are completely unique. Like, gravity doesn't work for us. I
Right.
mean, whatever the thing is, right? It's just like kind of, it's kind of being funny, but
Right.
it's that idea that,
Calories
like,
don't matter.
the calories don't matter. Physics are different in my factory. I mean, it's just those types of things that you get into, and then they end up creating like alternate processes to deal than like standard things. So like typically in ERP implementations, what you see is people trying to customize it to do something wacky that doesn't follow normal like manufacturing rules. Like, think about manufacturing, you have a bill of material that drives to demands, and those demands get fulfilled by MRP, and then you either buy them or you make them, you track the costs and you ship, all those are quote to cash kind of process that you see in most ERPs. And then they say, well, no, we do this. We're completely different. And then they say, well, we're going to create this alternate process to deal with that. And I actually was going to show that in kind of a visual real quick. Let me show that in a visual kind of way of how I see this happen a lot of times with companies. Maybe that'll help with the, at least if you're watching the YouTube version of this, but if you're on the audio, I'll have to explain it. But let me show this real quick of like how this would work. So share the screen here. So let me know, Jeff, when you can see it.
Yep, all good.
Okay, cool. Yeah, you see this kind of one. So just real simple, like 4-step process here, right? And so you think about this being like like BOM, and then you have MRP, right? And then you have then you're going into make versus buy, or shipping, or whatever the process is, right? And most things follow through this process, and like most ERPs and stuff are structured around kind of this process of making stuff. And then you can make this analogy with any process that's out there of like how people do things. But what happens is they think that they're like that doesn't match what we do. We have this variation, so we actually have this completely, so that works for some of our stuff. And then we have this whole other process that we use that's in parallel, right? It's up here, and where they do things completely different. And then they think of it like this, right? Like, I'm going to have another process that I have to maintain in parallel that also has like 4 steps or 5 steps or whatever, right? And so now they're maintaining kind of two separate ways of doing it, right? There's 2 distinct processes, and then it gets worse. I mean, they create a third one because they got another special case that they're dealing with, that they're trying to work with, right? And you got to think about what's the overhead of maintaining that, of like thinking about all of those processes, right? There's like, you got to have you gotta have training for every one of them, right? You gotta
Mm-hmm.
have like explain that. You gotta have, and you say, well, and then you have to have like logic. Like when do I use this one? When do I use this one versus that one? Right? You don't know. And so a lot of times this is what you see tends to happen. And then like people will try to implement systems over and over again. And then these systems are just kind of collapse on themselves because there's just so much complexity and there's so much overhead in maintaining all of these different processes. They just don't know what to do. So a lot of times the way I advise, I remember when I used to do this, like, and so now kind of the way I would describe it is like, instead of like, just trying to erase some of these things, instead of thinking about all of these processes as being different, there obviously is a driver that's keeping you from thinking like, well, how similar is this to that? It's like, what's causing that? And you're like, well, actually, we had a great example of this. We actually had a customer who made labels, like wine labels and stuff like that. And they had all these, this is years ago, and they actually had, they had to track like certain, they were doing like slitting of the rolls, and they had all these special tracking they had to do of like how long the rolls were and like lot tracking, all this kind of stuff. It was really complicated. And they were just thinking they were gonna have to come up with this completely alternate process like I show here. And then we were like, you know what? Like once you get the orders, you enter the orders in, it really doesn't deviate that much from a traditional kind of ERP process. It's just you're taking something, you're taking raw material, you're doing some operation to it, you're turning it into something else, and you're selling it. And you might, and then and it's typical lot tracking. You got to keep track of what went into it, went out of it, things like that. So it wasn't that different. So instead of creating like this completely alternate process like you're seeing here down at the bottom, we looked at it and say, you know what, where is the variation in this process? The variation is actually right here in the beginning, like an order entry. So if the beginning is how the order was entered, right? The order entry, that process was different. But like that still drove to customer orders, right? Which then drove to production. Okay. And my handwriting is horrible here, but my production, right? Those are still in process, but the order entry process, if they had to enter all of these different roles and everything manually, would have taken hours and hours and hours. And that's where they kind of got hung up. They're like, oh, I've got to do all these extra work. And I couldn't possibly use the existing process because order entry is really hard. So they were trying to create a completely different set of screens and different database and all these things, just completely customize the ERP to make this work. And then so we were like, wait a minute, if the order entry is the hard part, why don't we just make order entry easier instead of trying to re-engineer the whole process? Instead of trying to change all of this, let's just make this easier and then feed into the normal pipeline of how ERP works. You see what I'm saying there?
Yes.
That way, you drive the variation to as few steps as possible, but then you're able to take advantage of the proven area. It highlights some of this stuff here. So you're able to take advantage of like these proven steps here that have already been debugged, have already got processes defined around them and everything else. You're just making that one part with a variation slightly different and optimized for that variation, but still taking advantage of the pre-built tool to do everything else. Does that kind of explain that pretty well?
It does. If you can boil that down into is essentially it's kind of the 80-20 rule to a certain extent, right? You're saying if 80% is the same, then use the 80% that's the same. Don't just because you have 20% of variation or even 30% of variation or 40% of variation, it's still worthwhile to keep the things that are the same and only deviate or change where it is different or complex.
Mm-hmm. And another way to think about that too is like, but sometimes I'll say like, in this case, they'll say like, well, there's it's 10% different here, 20% different here, 30% different. They don't know, they can't consolidate the change,
Right.
the difference. So what you do is you could actually engineer the process to where you put the complexity here, so it's to drive it to look like there's no change here.
So you only have the complexity in one place.
Yes, and that way it's so you're like I think about this like a data pipeline or a process pipeline. How do I make it look like it fits like a puzzle piece into this pipeline so this pipeline can deal with it, as opposed to trying to change the pipeline all along the way to deal with the complexity. Does that kind of make sense?
Yeah, it does. Because if I understand you right, it's about setting it up so that it goes in. I'm trying to think of a metaphor, an analogy, but like essentially, you have a pipe, right? And how do I form the data or form this thing to go through that pipe, right? The pipe's a
Mm-hmm.
certain shape, and we know the pipe is strong. It carries water. It does all the stuff.
Yeah.
If I can just get everything else in that shape, I'm golden.
Yeah. Here's a great, let's keep with that example of the plumbing, right? If, it's like, I want to put garbage in my pipe, but I don't, but like, I don't want to make a bigger pipe there because like, some things I put in there might be bones and pieces of things that just won't fit down the pipe. But if I put a garbage disposal on the end and it grinds it up in little
It
pieces,
flows
it fits
through.
the pipe just fine.
Right.
And that you do a similar type of an idea with a process. Like, how do I drive the complexity into it? Because like a lot of times, like in this example of the order entry, they were trying to keep track of this entire thing all the way through this entire like order entry thing all the way through the process, which is causing customization of all these different steps, right?
Right.
But instead, we were able to drive this and just create more records here, 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 here that look like normal records. So the problem was they were just trying to save the time of creating all the records by consolidating in one screen. But we just said, oh no, you can still consolidate in this one screen. We're just going to make all the records here and then deal with them through automation downstream through the normal process. But they kept thinking they had to work with everything together, but they didn't. They just want to enter it all together where the humans were involved.
Yeah.
Software was handling all this.
Right.
So it didn't really matter that thing kind of traveled together. It just, all it mattered was that it was easier to do the hard part, which is actually getting the order entered. And that was like an interesting, another concept we see probably that's very similar to this is around the, people will try to do a lot of things with weldments or jobs. So like when you take a bill of material and a lot of times it goes through MRP and it generates a bunch of different jobs, right? So you'd say like, let's do a new one here.
So
Yeah. So
jobs, just be everybody, because people who are listening, right? It's all these different terms, right?
yeah.
Jobs or production orders. It's the things that get shipped to the shop floor, right? Because they're called jobs or shop orders or production
Right.
orders or things that go to the shop floor, right? They're orders to either manufacture something or purchase it or something. Essentially, it goes along with the traveler on the shop floor. Just so we can make sure we have
Exactly.
everybody on the same page in terms of what a job is and what he's using as a job.
Exactly. So like if you say all these parts, this is a bill of material, part number 1, 2, 3, 4 are all manufactured things, right? Sometimes there might be purchase things in here, but like in order traditional ERP, like this, and this are all jobs. There's one job to make part number 4, 3, 2, and 1, right? And all those jobs go out in the shop and then they come together and there's usually a job to assemble 2, 3, and 4 into one. And then there's usually like a job to make 2 out of some kind of raw material. And they all have different routings. They all go throughout the shop in different ways in order to come together to make one. And that's in order to make this one part, this one assembly, I've got to create 4 jobs, right? And that could be a lot of work. And because what happens is you have to transact on every operation for each of those jobs. And then you have to close that job and put it into inventory. So there's all these transactions. So that 4 jobs could translate into like 25, to 50 transactions
Right.
that have to be done in order to make that one thing. And what a lot of customers say is they say, "Oh, that's a lot of work. I don't want to close all those jobs. That's just like a ton of like, we just don't have the people to do that. And there's all this extra work." And so what I'm trying to do is they try to do like a flattening of the bill where they say part number 1 is, instead of having like indented bills where you have like, part number 5 under here, they'll just say, give me part number 1 and just give me all of the raw materials that make it up, all the components. And then we're going to have one big routing that goes through all the different machines. So it's just one job that makes the entire thing, all the parts that went into it, and also the top level. So now I've gotten rid of 4 jobs and I went to 1 job and I have less transactions. So there's less things to close. There's less complexity. So there's less complexity in the operation, right? The problem is that they've essentially masked some of the benefit of the ERP, which is, planning the work, figuring that out, and also to know the granularity of the cost of any given any one of these items. You don't know where the cost is because you're rolling it all up as one big thing inside of this thing, right? And so they're essentially changing the bill of material structure and and getting rid of that complexity, which also gets rid of data, information they might want to have in order to solve this problem of closing or dealing with lots of jobs, right? So go back to the example of like, well, yeah, that's one way to solve it, but where's the core issue at? The core issue is in the management or the closing of the jobs, not in the fact that the jobs exist. So one of the ways that we advise people to solve this is like, well, if the problem is in closing the jobs, why don't we just make a utility that automatically closes the jobs when it automatically closes the jobs when they hit a certain state, so that doesn't have to be done by a person, and then there's no downside to having all the jobs anymore, and then the system can run like it's designed to run with all the data that it needs to knowing what each part cost without the extra work of having to close the jobs, and you didn't change the process or how it worked and created a completely separate process. You're able to use what's already there the way it was designed without the added complexity of trying to flatten the bill and all this other kinds of stuff. You just figure out what the bottleneck is in that process and alleviate that. Where's the complexity and drive it to there? Does that kind of make sense?
So we talked about this when I first started years ago, but you have a couple of problems, right? Is you simplify what you think you simplified, but then you gave up a bunch of things in this example. But you also drove all kinds of complexity back into engineering, because engineering and the CAD side, you have a structured bill of material. So I've seen customers where the production, because they wanted a flat bill, ended up forcing engineers to change how they design to make it so that because they were using an integration, maybe they were not using CAD talk, but they're using an integration. They said, "Oh, okay, we need to have the CAD's got to look again. The CAD's got to look like the ERP, so we need to flatten it in CAD." And so you end up getting these designs that are all mucked up, and the engineers, it's harder to design, and you drove all the inefficiencies of closing the jobs back into someone else's job, right? Someone else now has what they're trying to do with their role is now affected because they have to change what they do to supply you what you need, rather than handling that in the best possible solution, which is to let everybody work what's easiest for them, and then like you said, drive the complexity to one area and then let everything else work the way it is.
Absolutely. And that's like just thinking about systems a little bit differently, right? So let me go ahead and unshare, but if that's a way of like, that's at least the way I think about systems a lot of times when I plan, when we think about product, or we think about like, how do we, when you used to ERP implementations, or you think about like how people use things, it's like they want to add complexity because they see variation. And the variation exists. It's legitimate, right? There's legitimate variation in lots of things. We talked about that earlier. But how do you isolate that in a way where you're still able to take advantage of the best practices that already exist and able to take it? Because you can't reinvent everything. Like if you say, well, like this thing isn't any different. Like you said, the idea with the pipes, right? Like I can't change all the pipes out in my house because I want to put bigger stuff down the drain.
Right.
But I can add a garbage disposal on the end to make everything small.
Yep.
And deal with that. So I really like that analogy. That's a good one. So just thinking about the process more and more like that, because you want to take advantage of the ecosystem that you have in place. And I think people overestimate their ability to understand complexity and how easy it is to change out. Like they see this a lot of times in code. Everybody else's code sucks. My code's great. And so we're going to do a great rewrite, and I'm going to do this thing so much better than last time. And then the guy forgets about all the little bugs and everything that was fixed along the way and all the little nuances that had to be accounted for. And you have to relearn them again because somebody decided that they thought they had a better way. I'm going to create a completely new thing that nobody else has seen before because I'm a special snowflake. And it's just, it's a certain amount of arrogance. It's similar to like the arrogance of thinking you know the language.
Yeah.
Just because you knew the base language.
Yeah.
There's a lot of nuance to that. You still can't order food.
No, a lot of nuance. Yeah. very easy to think you know more than you do, right? That think you know because of whatever, right? Like, oh, I've worked with these things before, something similar. This is just like that, and you're right. And the initial go, it is, and it helps, to your point, it helps you lock on to the new thing faster, right? The new subject faster, or to your understanding, accelerate your understanding. And then I think it's even part of the Dunning-Kruger effect. Same with business about the informed pessimism, right? Was that uninformed optimism leads to informed pessimism that changes back to informed optimism. Very similar, I think, to the Dunning-Kruger effect, which is like, oh, I know a lot about this. And then as you go, then you come back down and go, oh my God, I don't actually know anything about this. And then as you keep going back, right, you go, yeah, I know stuff, but there's still a lot of stuff. There's still a lot I don't know, and that's okay, right? I can figure it out.
Mm-hmm.
And it's very similar. Those two concepts are very similar. I think it might be in the same kind of idea, right? Where you can tend to, in the beginning, like oversimplify or think it's like, not what it is.
Yeah, and it's like, and it's funny, it's not, these things exist on a spectrum, and you have to kind of dabble the one end to the other depending on the effect, because questioning, you want to, like, so you say, well, wait, Scott, you just said not to question what we've done in the past because you don't know all the nuance that went into it, and you may be breaking something you don't realize you're breaking. And you're like, yes, you should think about that. You should consider that. And you go, but most of the major innovations are done by somebody questioning the original principles and then going back to first principles and seeing why we even do that to begin with. Yes, that's also true.
All that's true.
So
that's why it's so damn hard, because
it's why it's hard. Yeah,
both were true at the same time. Both were true at the same time.
Yeah, it's a dichotomy that you have to manage. There's no truth one way or the other. It's just like, because you can make huge advancements by questioning the reality of like does MRP have to run this way? Do you have to run a manufacturing company like this? Do you have to do that? No, you don't. But but at the same time, like, some of these things have been proven over time. They work really well. So, like, what level of change do you want to reinvent the way manufacturing is done along with a new product, or do you want to, what problem do you want to solve today, right? Because you could very well find a completely new way of doing something. But I think the idea is having enough understanding and understanding where on the spectrum you need to be at what time. And I think a lot of people are thinking like, I'm doing something revolutionary. It's this different thing in the world, and I'm going to reinvent everything. And you just don't have that kind of capacity, and you're in for a world of hurt a lot of times. So usually you have to get to a higher level of understanding before you start saying, you know what, this thing right here, this part in the process, I don't think it really matters anymore. Technology has eliminated the need for that. Let's check. Oh yeah, I guess that worked. But because you still want to question it over time and refine, but you also want to know where like the complexity lies. You're like, well, I don't really understand. Like, I would not change anything until I understood it really.
That's a good point.
Right.
They even talk about that for leaders when they come into new organizations, right? That's like the tip. If you leave one job and go to another and you're in a leadership position, the first thing is don't change a thing. You have this desire to change, right? I'm good. Like, that's why the new system. I'm going to get this new system. Our new job. I'm going to change it all. I'm going to mark my mark. And then what happens is, like, you should know, just don't change everything all at once, because you're going to throw the baby out with the bathwater.
Yeah, because you don't understand enough about why it does what it does. You just and so you can go back to first principles and ask that, and then find out. And that's kind of like Elon talks about with the algorithm, like, we question all requirements. Well, yeah, you should absolutely question all requirements, but until you question all the requirements, don't start cutting the requirements out. Because you don't know, you don't just get. I think it'd be arrogant to believe that you understood why everything was done the way it was done. Investigate, question it. But don't try to create a completely new thing or new alternate process just because it just looks stupid.
Yeah, a little sheepish. I wish I could say I avoided that in my life. I wish I could say that. That's just not the case. I've made lots of those throughout life. Lots of those assumptions that I knew better.
Yeah. Oh yeah. It's common. It's a very common thing. I mean, I have to resist that. I resist it myself, and I have to teach our development staff that you always get like a new developer comes in, and like I said, and he just thinks like, I don't understand this, therefore it must be wrong.
Yeah.
And you have to know that, like, that's not necessarily true until you understand it more. And then you might say, well, why did you choose that? Why did you do that? And they go, well, we did it. If they remember, hopefully they go, we did it like this. And you're like, is that still true? Is that assumption still true? It's a good assumption. Like, based on that assumption, you did an excellent choice there. But is the assumption still true? No, it's not true. Well, then we can make a different choice. But if you don't remember the assumption, then you're like, I don't know, like, what was it? Maybe there's something weird that happened here that caused that. I don't know. And then so you go back to complexity. So yeah, the complexity that exists in everything, in every, like, that's just manufacturing, that exists everywhere. So there's ways of doing it. So you have to kind of work on that spectrum between those two different kind of extremes and to figure out where you are. But generally, understanding it more, understanding kind of how things work, allows you to play around more with what you can change in, change out, and how much, and how simple you make things or how complex they need to be as well.
Well, I think that's a good tip to leave the listeners with, in terms of, I think, just generally, right? Like not just at ERP implementations or CAD, or even CAD, any of them, any software or any application or anything, is really about kind of 2 points, that dichotomy that you talked about. I think as when you approach these things, it's a dichotomy, kind of 2 things. Don't assume, or don't be so arrogant to think that the decisions you made in the past were bad decisions and didn't have good reasons. At the same time, question every decision that you made in the past, those assumptions, and are they still true? And can they be, is the technology or the situation different today from when you made the decision the first time? Those 2 things have to happen at the same time. And it's that balance that you have to get to, that Goldilocks zone.
Yeah. And then and where, it is my system, is what I'm looking at that much different than what's normally there? Is it really that much different? And
I know for years we suffered from, maybe not you, I can't say you, maybe me, suffered that, like, well, CAD talk is just different, right? It's just different. And it's like, well, different from what? Like every other software company out there? Hardly different from, different from any other company that delivers services. Any other company? No, it's not different.
Right. Exactly the same issue. It's just figuring out where the constraint is and relieving it, so you can take advantage of what works with all those other companies. So it's the same. So that's what makes software work, because you can apply a pattern to a business. You can apply a pattern. You do pattern recognition, and then you can extract efficiencies with software of that pattern to get the similar results. And if you're trying to make a new pattern for everything you do, right, it's really hard. It's really hard to make software work.
Yep. Well, that's good advice. This was a good conversation. I liked covered all of those, some common manufacturing challenges and complexity, and I think there's more thought about like how to handle that. Of course, sharing a little bit of where at least myself went wrong. So I always blame it on my youth, right? A friend of mine used to call it old man wisdom, right? When you're young, you don't have old man wisdom. Then you get old and you get old man wisdom.
Yeah, exactly right. Exactly right.
Well, Scott, that's a good conversation. Thanks to all the listeners. If you have any comments, please put them, comment, like and subscribe, share the content. We're looking forward to it. I'm going to be traveling quite a bit in the next month, in June, at several conferences. So maybe you'll see me there. And if not, we'll see you back on the podcast, Scott.